everyone, and welcome to our 60th episode in our space shooter DevVenture. So, by the end of our last live stream, we had come to the point where we need to test. Here we go. So let's just go over the last prompt I wrote and what the response was, because I remember we ran out of time before I actually went over all of this and started implementing it. Okay, so let's just read my prompt and then we'll go through the response, kind of figure out where we were, what we need to do, and get to it. All right, so I wrote, thanks for the help. I've implemented those changes as you suggested, and for reference, that was the improvements to the flea behavior, so that we could make it limited. Yes, okay, so this is the limitations on flea, the timeouts, right? So it times out by a timer, or it times out by distance. And so I've implemented all of the steps that it recommended, and then I said, okay, now I've done them, and now we are just going to need to test this new functionality and make sure it works as expected. Let's begin by thinking about the ways we could design a deliberate failure case in the testing seek behavior.tscn environment. What do you think? And in response, Perplexity wrote the following. The cleanest way to test the new flea failsafes is to deliberately build situations where safe distance is impossible, but flea keeps on trying. That way, the only way out is for a flea timeout or for a flea distance limit to be triggered. Here are three concept setups, or my mistake, three concrete setups you can try in testing seek behavior.tscn without changing the core code. Number one is to box the ship in. You box him in with non-destructible obstacles, right? So you enclose the area around the enemy AI or the AI actor. You enclose that ship up in non-destructible collision objects. So in the case of a pirate ship, that would be mining objects, right? So asteroids or anything else that can be mined, something that cannot be destroyed by anything that the pirate vessel has in its arsenal or at his disposal, right? So he can't shoot it, he can't fire torpedoes or missiles or whatever else it might have. No weapon can damage these objects, and it has to be avoided. And if he's surrounded by these avoidance objects and not destructible objects, then he'll continue to avoid and avoid and avoid until something happens. Either it runs out of space or it runs out of time. And so that's the first one. Box it in to make it impossible to get to a safety radius in the cached flea direction. Place several non-destructible mining object or obstacle meshes around the ship's starting area. So use 3 to 4 large asteroids or mining chunks forming a loose ring. And then ensure they are all, well, in our case, it's actually more of a sphere than a ring, because remember, we're talking about a 3D volume rather than a 2D surface area. Anyway, ensure they are all in the obstacle or mining object group, so the danger sensor sees them, right? Then position the ship so that its initial danger position is roughly ahead, and the cache deflection flea direction points into another obstacle or just keeps it inside that sphere. So just replace ring with sphere each time, right? And then you set flea parameters in the inspector. Like safety radius is reasonably large. The maximum flea the duration is fairly small for testing, and the flea max distance is small-ish, right? and then trigger a pattern that will enter an obstacle's danger radius. For example, find waypoint or attack towards a waypoint behind the obstacle, or you simply press I to manually start flee with a danger position inside the ring. The expected behavior is that flee starts, tries to move away, but because the ship is effectively boxed in, it never reaches the safety radius, and after max flee duration or max flee distance, you should see the flee timeout or flee distance limit failure logs, and the override lane cleanly exits. Okay, then the second approach is to use an unreachable danger position. So the goal here is to create a flee that chases a so-called phantom safe zone. In enemy ship controller.test attack pattern or a dedicated debug method, we temporarily pass a danger position that is unreachable. And for example, far outside the play volume or behind invisible blocking geometry. Or within a blocking geometry, right? So you put it inside a collision object. Go towards the center of this mining object. And it's like, I can't, I have to keep avoiding this thing. And eventually it'll time out somehow, right? Time out by time or time out by distance. And make sure no real obstacles actually trigger completion via safety radius along the flee direction. And then use a moderate maximum flee duration and a low maximum flee distance. What is expected is that flee runs in a direction that never gets enough separation from danger position. This hits the time or distance limit and emits a failure, letting you verify the path without changing the normal danger sensor pipeline. And the third approach is to align danger and flee so safety is never reached. Right? And the goal here is keep the ship perpetually not quite safe. You set the danger position and the flee direction so the ship moves roughly around the danger at a fixed radius and not directly away. For example, you give flee a deflection angle near 90 degrees so it skims around the object rather than directly away, and choose a safety radius slightly larger than the geometric distance the ship tends to stay at. So safety at 60, where the path keeps it about 50 away. All right, and then again set a small maximum flee duration or a maximum flee distance. And what is expected? The ship never crosses the safety threshold, but keeps moving, and the failsafe should eventually fire. All right, how do you observe success? In all these cases, for the test you want to see, flee activation line with a starting position and a flee direction, no safe distance reached line, a clear flee behavior timeout or flee behavior aborted, maximum flee distance reached line with your debug data. And then on behavior completed, treating it as failed and still unwinding the override state cleanly. Once you've tried one of these setups, share the log and the current flee inspector settings, and then it will be easy to tune radii and limits so the behavior feels intentional rather than so-called, what it calls brittle. But there is one concern I have for the way we've set things up so far, which I want to address now with Perplexity before we move on to testing properly, just so that we can do a proper job when the time comes. So let me do that, okay? Let me ask for Perplexity what it thinks about my suggestion. There's a case I don't think you've considered yet. What happens to the timeout when an interrupt behavior gets interrupted? What I mean is, if the AI actor is already fleeing, already performing an interrupt flee, and it hits the danger radius of another obstacle slash avoidance object, how does this affect the countdown that was running in the first behavior, the first interrupt behavior, when it starts the next interrupt behavior? Do you understand my question? If so, what do you think? Yes, this is an excellent edge case that I overlooked. Right now, the current implementation has a bug for exactly that scenario. When flee number 1 is running with flee time elapsed is 2.5 seconds, nearing timeout, and it hits a new obstacle, danger sensor calls start override behavior flee new danger position, start override behavior sees in override is true and ignores the request, phase 1 guard. Flee number 1 continues with its old flee direction cached and old danger position. Flee number 1 hits timeout, emits failed, override unwinds, pattern resumes. The problem? Flee number 1 never updates to the new, more urgent danger. The flee or the ship flees from the old obstacle while barreling towards the new one. What should happen instead? For robust multi-obstacle handling, you want one active flee at a time, but it updates its parameters when more urgent dangers appear. For example, flee 1 starts danger A, then new danger B is detected, update flee number 1 so it's now danger B, and flee number 1 timeout, resume pattern. Simple phase 3 fix, update active flee. Update start override behavior in npc behavior manager.gd to handle this. That's the updated code. And then change when in override is already true and behavior name is flee, recall activate on the existing flee with new parameters. This resets flee time elapsed to 0 and flee start position, updates danger position to new obstacle, recomputes flee direction cached based on the new danger, and keeps the same override state, no pattern advancement. The expected behavior after the fix: seek goes through danger A, triggers flee number 1, danger B triggers flee number 1, updating, and then danger C triggers flee number 1 and updates it again until there's a timeout, and then it resumes seek. Each new danger extends the flee window by resetting the timer, but always towards the most recent threat, no perpetual fleeing, and the pattern context stays preserved. This is much cleaner than the current ignore new dangers approach and handles your multi-obstacle concern without major refactoring. Okay, so this is the behavior that we wanted to get towards. Remember, we said that we were going to build this on top, this layer on top of the foundational layer. And now that we have the foundational layer, we can go ahead and build this additional layer or advanced layer on top. Now, my apologies, I got distracted for a second and I lost my train of thought. Yes, okay. So in order to worry about the timeout being continued over all of the new interrupts, right? There needs to be a global timeout, right? So let's go ahead and implement these things but we need to question Perplexity on this particular aspect. Is like, what do we do with the global timeout? Because each of these new updates on Flea 1 doesn't seem to preserve the timer. It resets the timer each time, which was my original concern. It's like, okay, well, if you're resetting the timer every time, it's literally just going to bounce around. If it gets stuck in a sphere of avoidance objects or obstacles, it's just going to keep bouncing around from one obstacle to the next in a sphere the whole time, right? And it's never ever going to get out, and it's never going to stop because it doesn't time out. And that's not what we want. So how do you even solve that? If it gets stuck in a situation like that, how will we get, firstly, how does it get itself into a position like that in the first place, right? The only way I can think of is if you allow these asteroids or mining objects to be pushed around. If you allow them to be pushed around, then you could effectively box in some of these enemy pirates. You could actually box them in. You could move asteroids in roughly a sphere, or what they call a buckyball. I don't know if you guys have ever seen a buckyball from Buckminster Fuller's design, but I'll show you what it looks like. It kind of looks like a soccer football. The buckyball looks like this. Here we go. So a buckyball is just a collection of pentagons and hexagons that wrap up in a sphere, right? And if you have enough asteroids, you could make basically a sphere around the enemy pirate in a tight enough network that the pirate can never escape, right? And so it will bounce around like this, and it will never get out. And eventually it must time out, right? And if it times out, how is it going to get itself out of the situation, right? Does the danger radius get smaller and smaller and smaller and smaller until it finds an escape? Or does it teleport? Or does it just call for help? What happens, right? So we need to think about that. That's another edge case, right? The only way this could happen, by the way, is if we allow our level design to be randomized by an algorithm. Then there's a small, very small probability that it could make an arrangement like this and a ship could get trapped inside, right? Now, the only other way this could happen is if A, I deliberately set it up this way, which we are going to do in a test case, but I'm talking about like in a real setting, right? Or B, if we allow asteroids or avoidance objects in general to be moved, to be pushed around, like if you think of a game like Half-Life 2, you could actually move, pick up crates and throw them, or pick up barrels and throw them, right? And put them down and make configurations and things. So if you allow that, where you like push asteroids and collision objects that need avoiding, if you could push them around and make arrangements like the buckyball, that causes this problem too. So I hope that's clear, right? That this is an actual problem that threatens the behavior of my enemy AI or my AI actors in general, right? Now, if we don't put in measures to prevent this from happening, right, we're going to need to figure out a way to solve this case, right? So if the pirate comes into a situation where this happens, how is it going to get out of it? Well, one way we can think of is to reduce the danger radius incrementally every time it times out until the gaps between each of these radii are small enough that there is a hole punched through the hexagon, and then the pirate can go through that hole, right? The only other way I can think of is to teleport the pirate out of that space. And that seems a bit hacky to me, right? It's more of a last resort kind of thing. And the only other way we can do this is to make the pirate stop. Go to the center of the buckyball using the arrival behavior and just stop there. And basically just give up and surrender. It's like, hey, you caught me. I'm under arrest. I give up. I surrender. I'm not going to carry on. And then it's captured. It's trapped in a prison. It can't get out. And until one of the mining vessels comes and mines one of those mining objects, that pirate is trapped. It can't get out. So those are your three options. And I think you'd have to do a triage, right? Triage is usually used in the context of medicine, like emergency rooms and things, right? You work according to priority, right? So somebody comes in and you work according to priority of who has the most urgent case, who has the most severe injuries, who needs the most immediate attention, and who needs, all of like those kind of considerations, right? Because someone who comes in with a broken wrist is not as important as somebody who has a heart attack, for example, right? The person with a heart attack, his or her need is more dire, and so more attention needs to go to such a person. And therefore, you could do a triage here as well, right? So the first approach, of course, is the cheapest one, which is, you could actually think of it as well in terms of the stages of grief. Like you've got denial. It's like, no, I'm not trapped, and I'll bounce around the sphere until I find a way out, until you don't. And then what happens is like, okay, well, now you move on from denial into bargaining. You're like, okay, well, what happens if I reduce the danger radius of each asteroid and I go closer and closer and closer to each asteroid until I find a way out? And you repeat this incremental decrease until the danger radius is literally touching the collision shape of each asteroid, or it touches the collision shape of the biggest collision object in the collection, right? And at that point, if the pirate cannot escape still, right, then you triage back from that approach, you triage down towards surrender. It's like acceptance now. It goes, okay, I give up, I accept my fate. I'm going to go to the middle of the sphere and I'll just wait there until an opportunity arises where I can escape. So I think that would be the behavior we want, right? So pragmatic escapism. Keep reducing the danger radius, get closer and closer, take more risks until a hole opens up between the objects and you can get your way out, right? Now, I think that's enough of the buckyball. Let's just do this. There is one more consideration you forgot to talk about. We need the timeout to be global rather than local. Consider the case where the AI actor is boxed in by a sphere or a spherical collection of avoidance objects. Like a buckyball. And because it's named after Buckminster Fuller, it has to have an uppercase B, right? Like a buckyball or similar. Resetting the timer for each flea adjustment will make the AI actor continue bouncing around the inside of this sphere indefinitely. Perhaps there should be a local and global timeout. One for the immediate flea and another much longer timeout for the collective flea sequence, or for the entire sequence of flea interruptions. What do you think? You're absolutely right. Resetting the timer per flea update creates an indefinite bounce loop in dense obstacle fields like a buckyball arrangement. The ship will keep finding new dangers, resetting its timer, and never escape. The local timeout per flea run. Global timeout. Local timer could be 3 seconds per individual flea attempt, prevents a single bad direction forever, and global 15 seconds for the entire override episode, prevents perpetual bouncing. Concrete implementation. Add global tracking to NPC Behavior Manager. In the NPC Behavior Manager.gd, add near the other override fields the following, and then track the global time in the start override behavior like this, and then check the global timeout in on behavior completed like this. And then the expected behavior is that you've got seek leads to danger A, which causes flea 1 and starting it, right? The local timer is 0, the global timer is 0. Then you reach danger B and flea 1 updates, local resets to 0, the global 1 continues. And then danger C, flea updates, local resets, the global 1 continues. And in this example, it's just like using an example. It happens to be 8 seconds in the example that this is being shown here, right? Then flea 1 hits local timeout, emits failed, manager checks the global, 12 seconds less than 15 seconds, starts flea number 2, local 0 seconds, continue, right? And then flea 2 hits a local timeout, manager checks, global 18 seconds is greater than 15 seconds, forces an override timeout, and resumes pattern. The inspector tunables. Now you can tune per ship and have the flea node, maximum flea duration is 3 seconds, that's the local timer, maximum flea distance is 50, and then NPC Behavior Manager, maximum override duration is 15 as a global. The result is that single fleas cannot hang forever on local timeout, but dense obstacle fields cannot trap the ship indefinitely with a global timeout, and the pattern will always eventually resume. This dual mechanism is standard in robust AI systems and prevents both failure modes you identified. Okay, so that's that. We've got those things down. Now the only thing left to say is to mention the triage of reactions, right? In a case where the ship is trapped, because there is a difference between timeout and being trapped, right? So if you're timing out, like, okay, let me just go into Krita and draw this out, because it's easier to visualize with a drawing, right? So if we've got a situation like this, I'll just draw a circle because it's 2D, but imagine this is 3D, okay? Now I'm going to change the color to be white, set the size to 3 pixels, draw a sphere kind of like that, and put the ship of the player in the middle, make it red. This is the enemy pirate. I'll enable my pin, and for those of you who are wondering, I never really show the pin. It's a graphics tablet pin. Okay, so I'm going to enable that and we'll start drawing. All right, so we've got our, just zoom in here. Okay, we got the enemy ship over here. Just draw that something like that, and then change the color to a darker red just to have some accents. And then change the color to like a yellow. Okay, now what was I talking about? I was saying if we yes, there are two kinds of timeout, right? So the first one is if you've got a cluster of collision objects, right? So the ship hits a collision and avoids it, right? So this is case A. So we'll call this case A, or case 1. We'll just zoom in here, change the size to 2 pixels, and then just like call this case 1. Boxed in. All right. And then case 2 is not boxed in. So there's a timeout and then there's a distance reached. So there's 3 cases. Now let's do that one. I'll just separate them with a line. We use a green line just because something like that. Okay, and now we'll do case 2 over here and case 3 at the bottom. We'll just draw another enclosure like this, and then an enclosure like that. Okay, now we've got our cases, and I can actually write some text here if I wanted to and still have space on the side for something else. Okay, now back to the pen. We need to change the color back to red. Now we have our ship. Let's just throw that in. So we've got our enemy ship kind of pointing like this. And we've got our collision objects up here somewhere, right? So we'll just draw that. We've got a collection of collision objects. Maybe we set them up in a line. So we have one there, and one there, and one there, and maybe one over here. Basically, it's just a very dense field of asteroids. Okay, so this is another case. And what we want to do here in this case, of course, is to deflect away in a direction that doesn't cause repeated bouncing. So you don't want to go here, then deflect to here, then deflect to there, and deflect, and all, you know, continuously. You want to figure out that, hopefully, you can figure it out that if I go here, the best thing to do is not to go in this direction. It's actually to go in this direction. So I deflect this way, or I can deflect like this, or I can deflect maybe even like that, right? But this is cheaper. Remember, we don't want to do a full-on backwards bounce like this, because that is, in quotes, expensive. Okay, now I'll draw all the arrows and stuff in afterwards. I just want to do the separate cases. Right, now over here again, if I go back to pen, change the color to red, and I've got this kind of setup where the ship is over here, and it's already hit the avoidance object like there, and it's trying to deflect, right? But there's a line of continuous asteroids like this, and so it continues to do tangential evasion from each one, and it continues on, right? So the safety sphere after a while never reaches, because it's trying to get away from this one, right? And it never really hits the avoidance safety zone for this object, because it hits this one and wants to dodge that one, and then it hits this one and wants to dodge that one, and it hits this one and wants to dodge that one, and it keeps on going and going and going and going in a straight line, basically because it's walled in, right? So we'll call that case 3. So we'll say this one is case 1, this one is case 2 over here at the bottom. So this is case 2, and this one is not boxed in, not walled in. We don't put it in quotes. We'll just say cluster, cluster avoidance, avoiding a cluster of collision objects. Okay, and then here at the bottom we've got case 3, which is walled in, right? So case 3, case 3, we'll call this one being walled in. Okay, and if I change the color to like a gray, and I make each one have its own sphere. Then you'll notice that if I change now to the dodge vector of the pirate, that it never really escapes any of them because it keeps hitting the next one. Hopefully, well, I mean, in theory, it keeps hitting the next one, right? And it almost does hit the next one here. But imagine it didn't escape. It actually keeps going within the circles, right? And then by the end of it, it's trying to determine when enough is enough, right? Whereas here, you want the arrow to look like this. Okay. Now that I think about it, this should actually be a different color, something like red, because we don't want the actual arrow to have this direction. It should have the other directions, right? So let's just change that to be red, and then the yellow avoidance line should be something more like this. Arrow should be more like that, right? Now I'm going to change back to red and draw until it goes fully red. And then go back to yellow and make a nicer arrowhead for this one. Okay. And over here, the red arrow will show going like into, because we're heading for this one, right? So you want to deflect like this, which will then do this, and then do that, and then 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 out. So that's the consequence, right? But what is the, and then obviously that's the solution, and that's the result of bad choice, the consequence of a bad choice. Now the consequence of a bad choice for being boxed in or encircled is to perpetually bounce around the circle, right? Now that will look something like this. It will go like that, then like this, and then like this, and then like this, and then like this, and then like that, and then like that, and like that, and like that, and then dot, dot. And the dot line just means ad infinitum, right? And we can actually draw in a lemniscus, or sorry, not a lemniscus, a lemniscate for that infinity to indicate ad infinitum, right? Now that's the consequence. What is the solution, right? And the only way to get the solution is to actually draw in where the asteroids are. So let's just put in like a 5, switch to pen, and then just draw asteroids. one there, one there, one there. We'll just put one at each of the bounce points. Right, and then we go back to our gray color. We change this back to 2, and we just draw in our avoidance circles, avoidance radii. So something like that, something like that, something like that, something like this, and on it goes. Now imagine these are actual circles rather than ellipses. It's just easier for me to click and drag ellipses than it is to drag a circle, right? But you can kind of get the point, right? That these circles are actually touching and that there is no way out, right? And the solution in yellow will draw a reduced circle like this and show that it's being shrunk inwards like this. Towards a smaller radius, thereby causing an escape gap. Because we have reduced the danger zones, right? Then again, just shrink the sphere down. Inwards. So just and now you can see the gap is there, right? Because now the yellow circles are the extremities, and so it punched a hole between the two, and now the enemy can escape, right? The actor, the AI actor, can actually make his escape, or its escape, because it's an AI. Yeah, I think that's good. Now let's start actually writing those points down in Perplexity, right? So I hope that this is visualized for you guys, what I'm talking about and why it's important that we have these solutions in place. Now there should also be a global distance and local distance for the repeated flee sequence. Or for flee sequences. This means the AI actor will stop the sequence once it travels an absolute distance or has taken an absolute time, whichever comes first. And then also for the For the case where the AI actor is boxed in, we need to offer a solution to the problem, or the actor will continue repeating the same trapped behaviors ad infinitum. Ad infinitum just means for eternity, or for an infinite amount of repetitions, right? I recommend a triage of behaviors continuously reduce the safety radius continuously and incrementally. Reduce the safety radius per flea for fleeing after each timeout until the safety radius touches the largest collision shape in the collection of avoidance objects. So this is 1, and then 2. If there is no gaps, this will hopefully create a gap in the sphere or in the box, so the actor can escape. Though the actor has taken more risks than it usually would. Okay, and if there are still no gaps, if there is still no gap after phase 1 completes, then do an arrival to the center of the box and stop there in a surrendering fashion. The actor effectively gives up until the level is done, or one of the avoidance objects gets moved or destroyed out of kindness / stupidity by the actors that can influence those objects. I would mention the teleporting thing, but I don't want to. What do you think about this triage approach? Well, what do you think about this in general? Your dual timeout and dual distance idea is solid, but the triage escalation for boxed-in scenarios is exactly the right approach for graceful degradation. This creates a clean, or rather a clear progression from try to escape safely to take more risks, then surrender strategically. Complete robustness model. Local limits, global limits, triage on global timeout. Implementation plan, dual distance tracking, and then here's all the additional changes. And then step 2 is the triage state machine. Add triage escalation on global timeout, centroid computation helper, reset on pattern resume. Expected progression is this, which gives you predictable escape logic that takes progressively more risk until finally surrendering strategically at the obstacle cluster center. Perfect for a trapped pirate gameplay moment. We've talked about making quite a lot of changes over the last few messages. Please consolidate them into a step-by-step action plan that I can do in my next session, as I've run out of time for now, and I don't want to scroll up or forget when I resume working next time. Thanks in advance. Step 1, step 2, step 3, step 4, and step 5. Okay, so this is the work we'll do in the next session, and I have it now as a list of tasks that we can work through in the next session. So for now, I'm going to make a shout out to Cubes. Thank you so much for your continued support. He's our junior DevVenturer at coffee.com/mtkdev. And the rest of you are welcome to go check out my Coffee page and join the support, join the memberships. You can check the perks and decide which tier is appropriate for what you can afford and whichever perks appeal to you, right? And also for free, you are welcome to join the Discord server. The link is in the description of this video and all previous live stream videos as well. And then at the same time, you are also welcome to do a one-time donation on my Coffee page. You don't have to become a member and do monthly subscription payments. Additionally to that, you can support the channel by liking, subscribing, and sharing the link to this video and all the previous videos with anyone and everyone you think will benefit or find this interesting. And then also just engage with the content, right? So comment, share, comment in this in the for this video and previous videos. Join the Discord server and communicate with the community there. Anything that you can do to support the channel is highly appreciated, and I thank you. So by the end, I will then thank you now. So I'm closing off. Thank you so much for your time and your attention, and I'll see you in the next video.